Hi guys, I am Dr. G. Srinivasa Gupta, Professor from Department of Mechanical Engineering, VJEC Institute of Engineering Technology. Today we are, as part of Dynamics of Machinery course, we are going to discuss a concept on double block or double shoe brake. As we have seen in single block brake, the normal reaction due to the rotation of the drum on the block leads to a force thrown on the shaft, side force, which causes bending of the shaft. In case of double block brake, an additional load is thrown, bending of the shaft can be avoided because it consists of two brake blocks applied to the opposite ends of the diameter of the wheel, which eliminate or reduces the unbalanced force on the shaft. What is the configuration of this brake? As we know that the brake wheel, rotating drum, okay, in single block brake there is a one block and it is attached to the lever, and it is the case. But in double block brake, this wheel consists of two blocks on both sides diametrically in opposite sides, and each shoe is attached to the lever. These two levers pivoted, that is, these two are fixed, and here this is attached to a rod. Okay, this consists of a spring. This consists of a spring. Then there is a fulcrum on which a bell crank lever is connected. If at all force need to be applied effort, then on bell crank lever we need to apply a force. Okay, so how it works? Because these two sides, opposite sides of the block is going to come in contact, the normal reaction on the block due to the from the drum is going to give the moment about the pivot in each block. If you take block 1, block 2, then the moment on the wheel shaft is going to be nullified because this is one direction moment, anti-clockwise, this is clockwise. So there will not be any bending of the shaft, wheel shaft. So that is one advantage. Second one is the frictional force become double, because if you take each block, okay, one block, let us say each block, then on the block the frictional force is normal force is Rn, and if let us say drum is rotating clockwise, okay, then the frictional force on the block is Ft. Okay, let us say Ft1, block 1. Okay, then how the brake is going to be engaged or disengaged? If we apply a effort on the bell crank lever P, then what happened? These two blocks will be pulled towards the drum. This force on this block. Okay, let me draw this one also, and this normal force, and this is connected with the lever arm. These two are fixed. Then this fulcrum, this one, and if you apply a force P, then there will be this, okay, P by 2, P is going to be applied because there is a spring will going to be compressed. Then that brings these two blocks together to the drum, and due to friction between block and the drum, there will be a retarding the motion or stopping the motion of the drum if enough frictional force is going to be affected. That is Ft2 here, frictional force. So this is very simple how to understand. Then the effort P, we as usual the distance between the center line of the block and the fulcrum, this distance and effort applied, this is one, and then lever length from the center line of the block and fulcrum, the distance L1, and this is effort, and the center line of the block is L2 if you take, then we can as usual apply moment equations and we can find whichever is required. Okay, effort P or the frictional torque, braking torque, or frictional braking power. Okay, so the total braking power in this case is becomes braking power, total braking power, torque, total braking torque, let us say it is Ft1 plus Ft2 into R, because we know that because Ft1 the torque is we know that that is into R, this is the torque on the drum, Ft2 into R torque on the total braking torque is Ft1 plus Ft2 into R, where Ft1 Ft2 are the braking forces on the two blocks or vice versa. Okay, I think you are able to understand. Then we will and one more thing, as we know that the contact angle of block with the drum is more than 60 degrees, then coefficient of friction, effective coefficient of friction we need to evaluate. Mu dash is 4 mu sin theta, 4 mu sin theta by 2 theta plus sin 2 theta. This relation we need to use if contact angle is of the block with the drum is more than beyond 60 degrees. That one you need to understand. Let us see by taking small numerical exercise problem and how we can going to apply in the place of double block brake. Okay, this is the problem C. A double block brake is applied to a drum of 500 mm diameter. Radius of drum is 250 mm, so 0.25 meters if we want in terms of meters, then 0.25 meters, right? The angle of contact of each block with the drum is 60 only, so you need not worry about coefficient of friction, angle of contact. Okay, this is 2 theta is 60, so you can understand. Then the coefficient of friction between the brake and drum mu is 0.35, and the normal force exerted by each block on the drum is, that is Rn1. If you say each block on the drum, Rn2 equal to 1500 newtons given. Okay, total braking torque on the drum you need to find, and braking power. Okay, when the drum is rotates 240 rpm. Okay, so how we can attempt this one? We can what is required? Total braking torque. Total braking torque, how we can write? 2 times, okay, braking frictional force Ft. Okay, here 2 times sorry 2 times Ft braking torque total, Ft into the distance. Okay, Ft is frictional force into radius. Okay, 2 times Ft1 plus Ft2. Sorry, if you say Ft1 equal to Ft2, then it is 2 times Ft into R. Okay, Ft, let us say Ft is 2 times mu Rn, as you know that. Okay, so then because Ft is equal to mu Rn, Ft equal to Ft1 plus Ft2, so 2 times mu Rn. So this is okay, torque you want, then Ft into R. Okay, so Ft into R. Ft is 2 times this one, and Ft into R is torque. You can calculate. You can see here. See, R is given, mu is given, Rn is given, speed of the drum is given, and number of blocks 2 here. So frictional force mu Rn as usual. So total frictional torque 2 into mu Rn, as 2 times. Okay, Ft as I have written already. So you will get 1050 newtons. And braking torque, after total frictional force into R. Okay, that is 262.5 Newton meter. Coming to the braking power, okay, this is 2 pi nt by 60, as you know that. Okay, N is given, and total braking torque you have already evaluated by 60. This is total braking power is 6.6 kilowatts. Okay, I think you are able to understand. This is so simple problem. as frictional force on each block is mu Rn. So 2 blocks. So 2 into mu Rn. That is total frictional force. So total frictional force we have done, and braking torque is frictional force into R, as you know. This is a straightforward and simple problem. You need not to take any moments about any pivot point, anything. Now coming to the little bit more this problem which involves theta contact angle is more than 60 degrees. Then this is the problem. A double block brake is applied to a brake drum of 400 diameter, means R is 200, R equal to 200 mm, so 0.2 meters, right? And speed of the rotating drum is N is 300 RPM, okay. Then each brake block subtends an angle 90 degrees at the center of the drum. So 2 theta is 90 here. 2 theta is 90 degrees. I think you are able to understand. Then coefficient of friction is given. Mu is 0.3. Okay. The normal force exerted by each block, that is Rn1 equal to Rn2 equal to 1200 newtons. So now the equivalent coefficient of friction it is asked. As we know that equivalent or effective coefficient of friction is equal to mu is given 0.34 mu sin theta by 2 theta plus sin 2 theta. Here you need to take care, while theta simply independently using in the relation, you need to use in radians only. Okay, 1 degree is equal to 5 by 180 radians. So whatever theta, you have to convert into radians. Then evaluate mu dash. So yeah, here you can see 2 theta is equal to 90 degrees. Each block contact angle with the drum is 90. So 2 theta is 90, theta is 45. Normal force is given on each block 1200. Speed of the drum is given. So equivalent coefficient of friction, mu dash equal to 4 mu sin theta by 2 theta plus sin 2 theta. While we convert this angle into radians 45 degrees theta, you can use the corresponding value. So from this mu dash we got 0.33. Is it okay? Then frictional force on each block. As we know that here you need to use mu dash Rn. Rn is normal force on each block. So frictional force this much. Total frictional force 2 times frictional force on each block. So braking torque is frictional force into R. Now the problem is similar. Okay, so T is equal to, you got 158.4 Newton meters. Braking power 2 pi nt by 60 as usual. So that you are going to get 4.98 kilowatts. Now coming to the problem involves taking moments about pivot and such case. Then let us take one more example. Let us see. Then here you can see this problem. Double shoe brake is applied to a drum of 500 mm diameter, rotating at 200 RPM. Each brake shoe subtends an angle 90, here also 90 at the center of the drum. The coefficient of friction between the lining and drum is 0.3. See, previous problem, you have calculated equivalent coefficient of friction, same value you can use. The brake is operated by a lever with the following dimensions. Distance from fulcrum to the effort point. Here distance from fulcrum, here we have the lever and this is the fulcrum to the effort point. Effort we have applied on each one block I am going to draw. Okay, effort we have applied on each one, this one. Distance from the fulcrum to the effort 400 meters. Here effort, here is fulcrum 400 meters, this one total. Okay, then distance from fulcrum to the line of action of normal reaction 120 meters. This is 120, this one from here to here. So this is obviously 280. So then determine the effort required to add the lever to apply the brake. P is required. Then you know that the frictional force, suppose drum is rotating clockwise, then frictional force Ft1 is this one. Okay, so the distance is, you know, and P is the effort here. Then you can take the moments about fulcrum. Then you can write the equation and you can solve this. So how, see, this is as usual radius of drum and coefficient of friction and angle, and you need to find lever arm distances L1 400 total length of lever arm, and this is 120 from normal reaction to effort. Okay. So then equivalent coefficient of friction, as usual, you need to find out mu dash. That is okay. 4 mu sin theta by 2 theta plus sin 2 theta. Then that you got the same 0.33 mu dash, and frictional force on each shoe as usual mu Rn, mu dash Rn. So total braking force 2 into mu dash Rn. Okay, braking torque F total into this one. But here effort required at lever. For this you need to take a moment. P into L1. P is effort required. In this diagram you have seen P into L1, total length 400. And this frictional force, normal force, because frictional force passing through this pivot point line of action, that is the assumption general. So it is not giving any moment. So Rn1 into this 280. So that is the thing you need to understand here. Okay, because two reaction, normal reaction, 2 blocks, 2 Rn into that 280 you need to write. I will write here P into total length L1 equal to 2 Rn into this is 280. Okay, you have to take care, and that P into 0.4 equal to 0.28 here. Okay, 0.28 in meters. Then you need to calculate P value. So then power absorbed you want to calculate 2 pi nt by 60. Okay, so here small mistake you have seen that Rn into this is not 120, 280 you have to use as per problem specification, distance specification. Okay, so I think you are able to understand. You can evaluate the power absorbed 2 pi nt by 60. Okay, T is P is effort. Then okay, already effort once you have that is required to calculate. You calculate it. Then power absorbed 2 pi nt by 60. T you know already we have calculated. Okay, T you have calculated braking torque. It is 165. So that you need to use, and you have to calculate power. Okay, only thing here is the distance from normal reaction to fulcrum is that is 280 mm. That is 0.28 you have to use. Not it is 0.12. Okay, with this I think you are able to understand. It is very simple. Only the difference between simple block brake and double block brake, there is a force thrown on the shaft that leads to bending of the shaft can be avoided, because the forces due to normal reaction on the shaft of the drum is going to be, the moments due to those forces are going to be neutralized. That is the thing you need to understand. Okay, with this I am concluding this lecture here. Thank you. We will meet again in the next lecture.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.